So the key formulas for today would be discounted dividend model. Okay, the first general model where we discount all the dividends we get from the stock, discount them one by one. So we have the stock price P0 hat, estimated stock price. We have the constant growth model version of this discounted dividend model where we have G as the growth rate for all the dividends. Okay, and we use the D0, the dividend that is given out at time 0, multiplied by 1 plus the growth rate of dividend divided by RS, stock return, minus the growth rate of dividend. Okay, which is also equal to D1, the dividend at time 1, divided by RS minus G, stock return minus growth rate of dividend. Okay, and this is equal to stock price. Okay, besides these, we would have a group of concepts where dividing total return into two components, dividend yield and capital gains yield. Okay, the total return of the stock equals dy dividend yield plus capital gains yield, CGY. And dividend yield of the stock is D1 over P0. Dividend at time 1 divided by original price. Capital gains yield is the change in price, P1 minus P0 divided by P0, the original price. Okay, so here are some key concepts we're going to learn today. Okay, before I go on further talking about these new concepts and models, let me do a small review here on what we learned in Chapter 8, Class 3. Okay, in last lecture, we actually were estimating stock price, RI, by using risk-free rates, RRF, plus market risk premium, RM minus RRF, multiplied by beta. Okay, so this RI stock return here is going to be used in our discounted dividend model as the discount rate, RS. Okay, so this RI, stock return for stock I, in our capital model is the same thing as the RS, the discount rate we use to discount dividends in the discounted dividend model. Okay, and for getting this RI, we need to know risk-free rate, RRF, or we can use RF to denote this measure, and it equals to R star, the real risk-free rate, plus IP, inflation premium. Okay, and we also know that stock risk premium equals RI minus RRF. Market return is RM. Market risk premium is RM minus RRF. Okay, and beta is the risk of a stock I in a well-diversified portfolio, beta. Okay, so we set stock risk premium, RI minus RRF, equals to risk-free rates, equals to the market risk premium multiplied by beta. Okay, this is how we get CAPM. The stock risk premium equals market risk premium multiplied by beta. Okay, so here is a review on Chapter 8, Class 3. And we're using the same RI here as RS in this dividend discount model. Okay, so let's first take a look at what is intrinsic value and stock price. And the stock price is simply the current market price, and it is easily observed for publicly traded companies. Okay, so when you go to Google Finance, Yahoo Finance, the stock price of Apple stock, the stock price of Twitter is the current market price. By contrast, in intrinsic value, which represents the true value of the company's stock, cannot be directly observed and must instead be estimated. Outside investors, corporate insiders, and analysts use a variety of approaches to estimate a stock's intrinsic value, P0. In market equilibrium, we assume that stock price equals its intrinsic value. Okay, so market stock price you observe in the market is decided by the buying and selling activities in the market. So it shows how investors perceive the risk of the stock and how investors think the stock market price should be for this stock. Okay, on the other hand, intrinsic value is our estimated true value of the firm, P0. Okay, we're gonna use two models we learn in we can use multiple models to estimate intrinsic value. Okay, and we're gonna introduce two of the most important models to estimate stock price in this chapter, which is dividend discount model and corporate valuation model. Okay, and in equilibrium, we think that stock market price is gonna converge to this intrinsic value. Okay, so outsiders or financial analysts, we could estimate intrinsic value by using the models, by using the financial models, and it can help us to determine which stocks are attractive to buy or sell.